Hi, my name is Asma Selwadi. I am a senior electrical engineer major at the University of West Florida. I am currently here at the Nanoscale Research Facility at the University of Florida working on my summer of undergraduate research project.
Deep brain stimulation is a neural engineering system that uses electrical currents to alleviate movement-related symptoms of Parkinson's disease. In this video published by the Wall Street Journal, DBS implanted patients demonstrate the significant reduction in tremors and freezing of gait symptoms when DBS is turned on. This project will focus on using wearable sensors to capture and analyze characteristics of freezing of gait so that they may be treated or even eliminated. This YouTube video, posted by Sarah Regare, depicts an excellent example of the erratic behavior of freezing of gait. As you can clearly see, she is trying to move, but her body appears to be frozen. I am being hosted for SURF by the Department of Electrical and Computer Engineering. I am working with Dr. Jack Judy, the director of the Nanoscience Institute for Medical and Engineering Technologies, as my faculty mentor. Parisa Tahafichi is my PhD mentor. We will be placing these shimmer sensors and the electrode probes attached onto the patients to gather information regarding freezing of gait. These Proto 3M boards will be used in conjunction with the sensors in our video data synchronization setup so that we can correlate our video observations with the data collected during their recording. Each of these wireless sensors has a 3-axis accelerometer, 3-axis gyroscope, and 3-axis magnetometer that make up their built-in inertial measurement unit, or IMU. These IMUs will be able to accurately measure the movement of the patient as they perform our tasks, which make them perfect for our data collection purposes, as shown by the data streaming in this video demonstration. The sensors can also gather electromyogram, or EMG information, by placing the electrode probes of the sensors onto the patient's muscles. The video data synchronization setup outputs a high value when the button is being pressed by one of the doctors. The doctors will only press the button when they realize that a patient is currently experiencing freezing. The circuit on the left uses an Arduino Nano and a radio frequency module to communicate with the receiver radio module when the button is being pressed. Hence, when the Arduino Uno receives a high value telling it that the button is pressed, it will light up the LED and output a digital signal to the MOSFET, which will convert that signal to an analog signal, which will be outputted to the Proto 3M board that was discussed earlier in this video. The Proto 3M board will be attached to a shimmer sensor that will collect all of this information and will allow us to examine the characteristics of the data collected from the other sensors that were placed onto the patient so that we can look at the exact moments that freezing had occurred during data collection. For further video demonstration, I had 4 sensors placed onto the tops and sides of my shoes before I walked across a pressure sensing mat just to give a visual for how data collection may be performed. I begin by standing on a regular doormat to collect stationary sensor information before I walk across the pressure sensing mat, which will provide me with further data regarding my walking behavior. I would like to thank Provost Joe Glover for sponsoring the SURF program, Dr. Jack Judy and Parisa Tahafichi for mentoring me, the Department of Electrical and Computer Engineering for hosting me, and Mike Nazareth and Julissa Nunez for all the work that they've done for the SURF program.